spent most of this chapter solving polynomial and rational equations. Now we're going to add another little piece that allows us to solve polynomial and rational inequalities. So you'll see a lot of the same work that we've been doing, with just a little added on to the end of that. Let's start with polynomials. And there are two ways that we're going to solve polynomial inequalities. One is by using the graph, and the other one is by solving algebraically. We'll start in this video by using the graph. When you use the graph, you may be using the graph from your calculator, or you may be using a graph based on the characteristics, the way that we've been doing it in this chapter. Remember that if you rely too much on your calculator, sometimes it looks like the graph flattens out when there's actually a little wiggle in the middle of it. So you need to be very careful that you're paying attention to the characteristics that we've been talking about. So we have this polynomial on the left, and we want to find out where the polynomial is less than 0. You always want to compare on your inequalities. You want to compare to 0, so you need everything on one side. We're going to look at the graph of the function itself, or just the left side of the inequality. You can easily see, since this is already factored, that we're going to have a 0 at 2, where this factor x minus 2 is going to give us a 0 of 2, and it's going to have a multiplicity of 2. From this factor, we're going to get a 0 of x equals negative 1, and it has a multiplicity of 1. So at x equals 2, the function is going to touch the graph, or the x-axis, but not cross it. And at negative 1, the graph is going to cross. The y-intercept is 4. If you put 0 in for x and do the arithmetic, you'll see the y-intercept is 4. So you plot those points on your graph. And we know that since we have x to the second power and x to the first power, eventually we would multiply those highest powers together and get x to the third. So our end behavior is going to be like a cubic. So it's going to have one arm down and one arm up, like this. And then that gives us enough information that we can sketch the graph in there. If you were to graph this one in your calculator, this is pretty much the graph you would see. There would not be any surprises. Now, the only way that the y values can change from being negative to being positive, or from being positive to being negative, is to go through a 0. There's just no other way for a polynomial to change the sign. So that's what we're looking for. We're looking for the zeros of the function, and then we want to know where those are going to occur on the x-axis, and if the y values are above the x-axis, then they're positive, and if the y values are below the x-axis, then of course they're negative. If we want to know where the function is negative, we want to know where the y values are below the x-axis, because that's less than 0. And those y values are these highlighted in red. Now we do not include the point that's on the x-axis because there's no equal to on our inequality. Our answer, however, is not the y values. The answer is what are the x values that give us those y values. So when we write the answer, we're still, in effect, solving for x. So for the x values from negative infinity to negative 1, not including negative 1, all of those x values give us y values that are below 0. You may be asked to write that answer in set notation, or you may be asked to write that answer in in interval notation. More than likely on the final, you'll be using interval notation.